Hey guys, you might be working through number section 4 in your workbook. There's a couple examples in there that might not be absolutely clear as to what it is you should be doing. So I thought I'd go through some of those examples here just to kind of clarify what's happening. So we're going to be estimating large and small square roots. And when I'm talking about small square roots, I really mean something that is smaller than 1, but obviously has to be bigger than 0. We don't have any negative square roots unless you're working with imaginary numbers, and there's no need for you to be doing that until you're well into university. Okay, so I want everything for our purposes to be positive, and we're talking about large square roots and then ones that have a value smaller than 1 but greater than 0. Okay, so what we're going to be doing is estimating to one significant figure. So that really means just the first number on the left-hand side that isn't 0. Okay, so if I was looking to do the square root of 6,610, okay, I want you to look over here. I got a reminder of all of the different perfect squares that we have, and you'll notice that all of the perfect squares from 1 to 9 are all 2 digits. Right? The perfect squares are all 2 digits. Even 2 squared, which is 4, really I could write it as 0, 4, so it's still 2 digits. And I don't hit 3 digits in a perfect square until I get to 10 squared, which gives me 100. Okay? The reason that's helpful is what I'm going to do with this value 6,610 is I'm going to go from the decimal point, which right now is to the right of 0, and I'm going to split from the decimal point. I'm going to split into pairs of numbers. Okay, so the decimal point's going to stay there, but I'm going to group the 0 and the 1 together as a group of 2. Okay, so when I'm estimating perfect squares, I'm always going in pairs of numbers. So I also have the 6 and the 6 now make a pair of numbers. Okay, so since I'm doing estimating to one significant figure, the only one I want to look at is this 66. Okay, so because that 66 is going to be the farthest left non-zero number, I'm now not worried about the 10. So I'm just going to estimate that as 0. So one significant figure means I'm getting like the nearest 10 or 100 or 1,000 or whatever my first digit is going to be. Okay, so what I'm looking at now is I'm looking at the square root of 66 is closest to what? Okay, the square root of 66 is really close to 8, right? Because the square root of 66 is really close to the square root of 64. Okay, it's close to the square root of 64. So the square root of 66 is going to be close enough to 8. Okay, so that means the square root of 6,610 is approximately 80. And that is as close as I need to get in terms of estimation. Okay, now if you were to type it into your calculator, it'll be a little bit more exact for you. So you get something like, I think it's 81.301906, and it kind of keeps going. And what the calculator is giving you is also an estimate, because those numbers keep going. They don't terminate, but there is not a repeating pattern. So this is not a rational number, it is irrational. So the calculator is also giving you its best approximation because it has now run out of digits to show you any more info. Okay, so both are estimations. Now the calculator is much more exact, but I don't need to be that close. Okay, I'm just trying to get a ballpark answer. I want to be within a reasonable range. Okay, let's do another one. So I'm going to work on, let's try something a little bit bigger. We'll go with the square root of, let's say, 82,741.3. Okay, so I'm going to do the same thing. I'm going to go from the decimal point, okay, and I'm going to start splitting into groups of 2. Okay, so from the decimal point, the 1 and the 4 get grouped together. The 7 and the 2 are going to get grouped together, and then the 8 is all by itself. I guess if you wanted to, if it'll help you sleep better at night, you could put a 0 in front and think of it as 0, 8 so that it has a pair, but that's not really necessary. On the right-hand side of the decimal, I'm going to do the same thing. So I have the 3, and then again, for a pair, I could add a 0. So I've got that there. So I still have the decimal point here in my answer. Okay. Now I'm looking for the first non-zero number. So the first non-zero number is going to be here, which means I don't need to worry about any of my other groupings. So this 2, 7 pair, I'm just going to round it to 0. The 4, 1 pair, I'm going to make a 0. The 3, 0 pair, I make a 0. So this answer is going to give me something in the hundreds. Okay, so I'm looking now for the square root that's closest to the square root of 8. Well, the square root of 8 is closest to the square root of 9. That's its closest perfect square. So that means it's really close to 300. Right? The square root of 8 is closest to 3. That's its nearest perfect square. So we get 300. So I'm going to write out 82,741.3 is approximately 300. And that's as exact as I need to be. I'm just looking for one significant figure. I don't need to work that hard. Again, if you type it into the calculator, you get a lot more information. 287.64787.5, and then blah, 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 blah. More numbers are going to keep showing up. But 300 is close enough to that. Okay, so that's really all we're looking to do is get close. Okay, now I'm going to do a couple that are smaller than 1 because we talked about that as well. So I've got 0.00241. Okay, so same thing, that decimal point is my boundary. So here we go, I'm going to use this as my first divider, and I'm going to carry that decimal point down. Okay, on the left, I've got a 0 and a 0, so that's just a 0, right? And then I've got 0 and 0 in this pairing, and that's still going to be a 0. So I have to write down those zeros. I have to write down zeros if there's not something on the left-hand side that's bigger. I got to put those zeros in. Then I got 24, and then I got a 10. Okay, well the 24 is the first thing that's not a 0. So I need to know what this number is. This last grouping with the 1 and the 0, it's not far enough to the left. The 24 came first, so this one is not going to give me any information, so I fill in a 0 there. So really what I'm looking for is I'm looking for the square root that is closest to the square root of 24, and the closest to square root of 24 is the square root of 25, and that value is 5. So the square root of 0.0241 is approximately 0.05. Okay, that's as close as we need to get. Here's what the calculator would give you. I think it's 0.0490917.5. Well, I think our answer is pretty close to that. Okay, all you need is that first digit on the left-hand side that is not a 0. Okay, and you put zeros in front if there's a decimal until you actually get there. Okay, I'm going to do the exact same numbers actually, but I'm just going to slide it over a little bit to show you how it changes. Okay, so just because I've slid everything over one decimal place doesn't mean that my answer is going to slide one decimal place over. Okay, watch what happens when we split this one from the decimal point. Okay, so we still get that decimal point down here, a 0 in front, but now my 0 and 2 are paired together. And this is now my first non-zero digit on the left. Okay, and then I got the 4 and the 1, but those guys are on the right-hand side, so I don't care about that one because we've already said our first non-zero digit is to the left of that. So the 4 and the 1 don't play a role in this one. So I'm looking for the closest square root to the square root of 2. Well, the closest perfect square to that one is the square root of 1. And the square root of 1 is simply just 1. So I'm saying that the square root of 0.0241 is approximately 0.1. Okay, now is that estimate perfect? No, not really, because the calculator does give us something where if I was to be rounding, I probably would round to the nearest tenth and I'd go up to 0.2, but we're reasonably close. Okay, we did actually have that first significant figure. It does match. So we were reasonably close. And that's all we need to do is get close to that first significant figure. Okay, so the one thing we want to be doing is we are going to divide into groups of 2, starting from the decimal point. And we're going to do that both going left and right from the decimal point. Okay, so that's all you need to do to estimate square roots to one significant figure. You just need to be in the ballpark. You don't have to be exact. You got your calculator for that. All right, see you guys.